In this video, we'll continue solving equations with squares and square roots, and the question will be to figure out the square root of what number equals 4. So our question this time is the variable inside the root, and it sounds like what number, square root of what number equals 4. Under the square root, it means you have a square, and how many units is the square if the sides of the square are 4? 1, 2, 3, 4 by 4, that would be 16 units. So square root of 16 equals 4. The square with the sides of 4 by 4 takes 16 units, so the square root of 16 units will be the side of the square 4. As a reminder, square root and square are inverse operations, and when we looked at 6 times 6, number times itself is 6 squared, which is 36. The inverse will be square root of 36, which is square root of 6 squared, where square root and square cancel each other. Therefore, square root of 36 equals 6. For variables, the same idea. A number times itself is called number squared. To inverse that, square root of y squared will be y, because square root and square are inverse operations. They cancel each other. So we're going to see another set of problems, and we're going to see the problem, which in this situation involves a square root. We'll see how to use the inverse operation to solve, and then check our answer. So for the problem, square root of x equals 5, the question is, square root of what number equals 5? Square root of 25 equals 5. Therefore, the value of x has to be 25. Why? Because square root of 25 is 5. Let's see how to use the inverse operation to solve this problem. In the equation, we had square root. So we're going to use the inverse operation, which is square. We are going to square both sides of the equation. Since in the original equation we had square root, we are going to use square as the inverse operation. Square root of x will be squared, and 5 will be squared. Using square root and square inverse operation, we cancel each other. X comes down. 5 squared means 5 times 5, which is 25. So your x value is 25. Check. We substitute the x value in the original equation. Square root of, instead of x, now we can use 25. Square root of 25 is a perfect square, that's 5, which is equivalent with 5 on the right side. So the answer, x equals 25, makes a true statement by being replaced in the original equation. Let's see one more example, number 2. Square root of what number equals 9? In other words, what was that square? How many units was the square of 9 by 9 size of the sides of the square? So in other words, if you think inverse, 9 times 9 equals 81. So square root of 81 must be 9. So square root of what was the square? Here is the question. What was the square? How many units it took if the sides measure were 9 by 9? 9 times 9, 81. So square root of 81 equals 9. Y equals 81. The y value must be 81. So that is the meaning of the problem, or how to think about what the question is asking. To solve using inverse operations, since in the equation is square root, we use inverse operation, square. So we are going to square both sides of the equation. On one side we square square root of y, on the other side we square the 9. So the original equation was square root of y equals 9. We square the square root of y equals, we square the 9. Inverse operation, square and square root cancel each other. The y value comes down, and 9 squared means 9 times 9, which is 81. So here is when we solve the equation using inverse operations. To check, we substitute the value of 81 in the y place in the original equation. So that means instead of y, I write 81, and I need to be getting 9. When you simplify square root of 81, that would be a perfect square, which equals 9, which checks out to be correct. One equals square root of t. The question is, what was the square? How many units did it take to make a square of the size 1 by 1? Square root of 1 is 1, because 1 times 1 is 1. So the t value, t inside the root here, t equals 1. That one is the meaning of the problem. How to solve the problem using inverse operation. Our equation, 1 equals square root of t, has square root. Inverse of square root is square, or second power. So that means that we need to use inverse operation of both sides, which is second power of both sides. On the left I had 1, on the right I had square root of t. 1 squared means 1 times 1 equals 1. Square root and square are inverse operations. They cancel each other, so I have t equals 1, which is the same value. To check, we substitute instead of t in the original equation. So 1 equals square root of 1. Square root of 1 equals 1. It's a perfect square. 1 and 1 on the left and right prove that the solution makes a true statement in the original equation. And one more example. What if I have 8 equals square root of a? It means how many units was that square that had the sides 8 times 8? 8 times 8 is 64, or square root of 64 equals 8. Square root of 64. 64 is a perfect square. 8 times 8 is 64. So our a value has to be 64. Why? Because square root of 64 is 8. Since the original equation contains a square root, the inverse operation is square, or second power. What that means is that I have to raise to the second power both sides of the equation, because when we use inverse operations, we do the same thing on both sides. So on the left I had the 8, I have to square that. On the right I have square root of a, so I have to square that. 8 times 8 is 64, and square root and square cancel each other. The a is the value that comes down, and that becomes a equals 64, or 64 equals a, which is the same value. To check, we use the value of 64 in the original equation, which was 8 equals square root of a, and now I can use 64 to simplify. Square root of 64 is 8, which is 8 on the left and right side, meaning that our solution makes a true statement for the original equation.